organic vegetable, organic food, organic pottery. So, what is organic? According to Wikipedia, organic relating to or derived from living matter. The synonym for organic is living, life, animate, biological, natural, and biotic. Another meaning is of food or farming method produced or involving production without the use of chemical fertilizer, pesticide, or other artificial chemicals. What is organic chemistry? Organic chemistry is the chemistry of carbon compound and then compound that could be obtained from living organism. So normally has hydrogen, carbon, and others common element are oxygen, nitrogen, halogen like chlorine, bromine, and then sulfur and phosphorus. Exist as simple or complex molecule. Can be gases, liquid or solid, and color or colorless. But not all carbon compounds are organic. For example, carbonate, cyanide, bicarbonate, and carbon monoxide are not organic compounds. All organic compounds consist of carbon atom. Then, what is the properties of carbon atom? First, has 4 valence electron. So, group 14, that's why 1 dot, 2 dot, 3 dot, 4 dot. There are 4 valence electrons. Then can form 4 covalent bonds. If we check 1, 2, 3, 4. 1, 2, 3, 4. Each of the carbon can form 4 covalent bonds. Even this one also the same. 1, 2, 3, 4. Okay. Next, 3 type of covalent bonds. Try to observe these 3 carbons bonding. What is the difference? First, single bond. Second, double bond. And this one is triple bond. That's why there are 3 types of covalent bonds. The structure of organic compound CH4. First, you look at this diagram. Okay, if you are using stove to cook, so you're quite familiar with this one. This is a natural gas tong. So inside the tong is methane, a component of natural gas. Next, this is the structure of glucose. A simple glucose. Normally, we will take care of the level of glucose, especially for the diabetes patient. So, use of organic compound can be in medicine, engineering, biotechnology, and agriculture. So, this is the specific organic compound for the various field. The objective of today's lesson is to define structural formula, show structural formula in the form of expanded, condensed, and skeletal structure based on molecular formula. 4.1 Molecular and structural formula. So please try to think what is the difference between molecular and structural formula. Structural formula is two-dimensional formula that show how the atoms in a molecule are bonded to each other. So you see there are 3 different structural formula. So what are the 3? First, expanded structure. Second, condensed structure. 3, skeletal structure. So based on the names, right, you can imagine expanded, you have to expand everything. Condensed, you squeeze into one structure, okay, without showing the complexity. Bra, bra, bra. What is expanded structure? Expanded structure that show how atoms are attached to each other but are not representation of the actual shapes of the molecule. Next, molecular and expanded structure. If you check, right, this one is molecular formula. It shows the number of carbon. There are 4 carbon, C4, 9 hydrogen, and 1 chlorine. So how are we going to draw the expanded structure? So first we need to show 4 carbon, 4 carbon, 4 carbon,
and 4 carbon. Okay, and then bonded to 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, there are 9 hydrogens. Here is chlorine molecule. So this is one of the expanded structure for C4H9Cl. Okay, how about alcohol? There are 2 carbon, 1, 2. Attached with 1, 2, 3, 4, 5. Okay, 5 hydrogen first, and then alcohol must be functional group O, H. So this is the 6 carbon. So this is the expanded structure for alcohol C2H6O. So the name of this alcohol actually is ethanol. Okay. Next, carboxylic acid. So there are 3 carbon, 1, 2, 3. Okay, carboxylic acid is with double bond O and then OH. So and then check 1, 2, 3, 4, 5. And then the 6 is over here. So meaning that you check each of the carbon is attached to 4 others atom. Okay, that's why as we discussed before, right, there are 4 valence electron or 4 bonding for each carbon. And then over here you can notice oxygen 2 bonding and then hydrogen 1 bonding. Please take note. So this is the way to draw the expanded structure based on the given molecular formula. Let's check. This is nicer because it's typing. Condensed structure. Structure that does not show single bonds between carbon and hydrogen atoms, but double and triple bonds are shown. And all atoms that are attached to a carbon are written immediately after that carbon. So for example, molecular formula C4H9Cl, we know the carbon is attached with 3 hydrogen and 1 carbon. So that's why CH3 is right immediately after the carbon. And then attached with the next carbon. So the next carbon is with 1 hydrogen and 1 chlorine. The bracket is represent this carbon attached with 1 hydrogen, 1 chlorine, and 1 carbon over here. Another carbon is with this carbon number 3. And then next, carbon number 3 is attached with 2 hydrogen and 1 carbon with carbon 2. Another carbon is carbon 4. So the last carbon is attached with 3 hydrogen atom and attached with carbon 3. So this we call it as condensed structure. Okay, for cyclopropane is cyclic compound. That's why we must show the bonding for the cyclic compound. So 1 carbon attached with 2 carbon and 2 hydrogen atom. So the hydrogen atom is right beside the carbon atom. Okay, CH2. So CH2, CH2, CH2. If you check, right, always must remember carbon attached with 4 can form 4 bonding. Okay, for this one, aldehyde. Aldehyde, so CH3. So CH3 attached to C with C, and then attach this C attached with 1 carbon with the carbon 1 and double bond O, and then this hydrogen 4 bonding as well, 2 single bond and 1 double bond. Skeletal. So what is the next? Next is skeletal structure. Structure that shows only the carbon skeleton. Hydrogen atoms are not written, and other atoms such as oxygen, chlorine, nitrogen, etc. are shown. These are the example for skeletal structure. Okay, so this is, okay, just now is CH3, CH, Cl, CH2, CH3. If you notice, right, how to, okay, 1 carbon, 2 carbon, 3 carbon, 4 carbon. So over here, 1 carbon, 2 carbon, 3 carbon, 4 carbon. So meaning that each point, right, is represent 1 carbon. And then this is special thing. Okay, this is not hydrogen, this is chlorine special. So the special atom you have to show chlorine. Okay, C1, C2. Yes, C number 2 with chlorine atom. Okay, next. Okay, this is cyclic compound. That's why your drawing must be in cyclic. Okay, so 1 carbon, 2 carbon, 3 carbon, 4 carbon. So tally with the condensed structure. Okay, and then this one, C1, C2, C3, C1, C2, C3. And then between the C1 and C2 there is a double bond. So double bond must be shown. And then at the C3 there is hydroxyl group. So you must show the OH group as well. Here, that's why skeletal structure show only the carbon skeleton. Each point or each tips equal to one carbon atom, and hydrogen are not written. Others atom, oxygen, chlorine, nitrogen, etc. are shown. And one more important thing is must show the double or triple bond. Just now what we learned is two-dimensional. Now we go for three-dimensional formula. Wedge, dash, wedge, line formula. What's that? Describe how the atoms of a molecule are arranged in space. Let's check one example. Okay, if you look at here, right? So this is dash wedge. Okay, point out. And then here is the wedge, point in. And then these two are line formula. Okay. So when you draw like this, right, this called as three-dimensional formula. Normally we have to apply this in chapter haloalkene, okay, to show the three-dimensional formula. Because we need to draw the mechanism for haloalkene, the SN1 and SN2, we need to show the three-dimensional structure. So this is others example for the three-dimensional structure for bromoethane. Okay, we can draw like this, okay, because there are 3 carbon, right? Okay, we can draw like this, Br, or we can move the Br over here, or we can move the Br over here, because it's a 3-dimensional structure. So when we rotate, right, the point of view is different. So this lines formula is bonds that lie in the plane of the page, while this wedge dash is bond that lie behind the plane. So line behind the plane. Remember, point in, and then for the wedge dash, point out is the bond that project out of the plane of the paper. Practice 2, there are 3 questions. Let's try it together. Question number 1, based on this condensed structure, we need to draw the expanded and skeletal structure. Let's try. 1, 2, 3. Okay, 3 carbon, and then there are 1 branches, 2 branches, be careful, 3 branches. So we need to draw 1, 2, 3 first. 1 carbon, carbon 2, carbon 3, okay, and then with the branch of chlorine, and then there's a branch of CH3. Be careful, we cannot straight over write out CH3, we need to expand the CH3 for the branch. There are 2 CH3. So here another CH3. Okay, don't forget, fill up the hydrogen for CH2 for carbon 2 and then CH3 for this carbon 1 as well. So this is expanded structure. Okay, C1 CH3, C2 CH2, C3 there's a chlorine branch, CH3, CH3. Yes, this is correct expanded structure. Now let's proceed for skeletal. Skeletal, okay, I draw it like this. 1 carbon, 2 carbon, 3 carbon. There is 1 branch, 2 branch, and then you must show the chlorine atom. Now let's check carbon 1, carbon 2, and then carbon 3 with the branch of 1 methyl, another methyl, and chlorine atom. Yes. Next, we are going to draw the expanded and condensed structure based on the given skeletal structure. So first of all, right, okay, I will try to draw the double bond first, double bond, and then with one carbon attached to the benzene ring with carbon, and then double bond. So carbon, okay, carbon, double bond, carbon, and then carbon, here carbon, then here double bond. So now we check. Okay, so here not enough bonding, meaning there is a one hydrogen. Each carbon have to have four bonding. So and then here there is one hydrogen, here one hydrogen, then one hydrogen, one hydrogen, then one hydrogen. So this is the expanded structure. Okay, one carbon, one bonding, two bonding, three bonding, four bonding. One carbon, one bonding, two double, two bonding, three bonding, four bonding. So each of the carbon, right, will have four bonding. Okay, and then make sure the attachment is between carbon and carbon. Okay, now we proceed with condensed structure. The condensed structure is much more easier because we just need to show the double bond O and a special atom. In this case, there is no special atom, just with the C double bond O. The rest is just carbon and hydrogen. So straight away attach carbon, hydrogen attached together. And then here, so everything still the same. Okay, carbon, double bond. Because this is a benzene ring, that's why I need to show the bonding. But for the CH, no need. We straight away draw like this. So this is CH. Okay, because this is condensed structure. Then double bond, CH. And then here CH, then double bond C, and here H. Okay, 1 2 3 4 5 6. So there are 6 carbon, and then here there's aldehyde. Okay, C double bond O also attached with one hydrogen. So actually, right, when you draw the expanded structure, it's much more easier to convert the expanded to condensed, because the difference between these two is the CH bond we no need to show. Expanded, yes, we need to show, but for condensed, we no need to show. But C double bond O still have to show for condensed structure. We are going to draw the condensed structure and skeletal structure based on the expanded structure. First, condensed structure, CH3, CH, and then the chlorine must put a bracket, Cl, because this is the branches, and then CH2, CH3. So this is the condensed structure. Okay, for skeletal structure, we know there are 4 carbons, so 1, 2, 3, 4. 1, 2, 3, 4. Then carbon number 2, there's a chlorine. Carbon 1, carbon 2 with chlorine, carbon 3, and carbon 4. So this is the skeletal structure. If the handwriting version is not suit with you, you can check for the typing version. So this is the answer, expanded, skeletal, and then this one condensed, expanded. And this is the condensed and skeletal structure. Thanks for watching. Next video is about classification of carbon and hydrogen.